In this lesson, we are going to be going over how to create entities using ECS. Now, there are many ways of doing this. The easiest is by creating one in the editor, although later on we will be looking at how we can create entities inside of our scripts. So, before we start, let's first of all go over again what an entity is. Now, an entity is basically like an empty box, you could say, okay? It's basically an identifier. You give the entity a name, and with that name, we can then link different components and data to it, okay? So a good way of thinking of an entity is, in a way, like an empty game object. By itself, the empty game object doesn't really exist, it doesn't really do anything in our game, but when we attach components and data to it, it then becomes something more. That is essentially the same thing with ECS, okay? But it is a bit different, and we'll go over the differences in just a second. So, first of all, how do we create an entity? Well, like creating a game object, we could right-click in the hierarchy, go 3D objects, and create a sphere or something, but that is just going to create a traditional game object with our traditional components that we are already used to. So what we need to do is, first of all, create something what is known as a sub-scene, okay? This is going to be something we create here in the hierarchy. So I'm just going to right-click, and then down at the bottom, I'm going to go New Sub-Scene, Create Empty Scene right here. We can then give it a name. I'm just going to call this one our entity sub-scene. You can really call it whatever you wish. And then, as you can see, it is going to be created right here inside of our main sample scene. Now, everything that we create inside of this entity sub-scene, that is going to basically be initialized as an entity. And I'll show you the difference. So, let's go ahead and create an entity. Now, this is basically done the same way as creating a game object. We right-click. This time, we're going to right-click on the entity subscene, and I'm going to go prefab, or not prefab, I'm going to go game object, 3D, and let's go ahead and create a cube, okay? So that's going to go ahead and create our cube object here as normal, but there's one thing you may notice, and that is down here at the bottom of our screen, we have this little preview window here that you can pull up like that called Entity Baking Preview. And as you can see here, we basically have a large list of different things, okay? Blend probe tag, chunk world render bounds, all of this stuff that you probably haven't heard of before. And these are our components that are basically attached to our cube entity right here. Now, it is probably looking a bit confusing because we also have our components here, such as mesh filter, mesh renderer, box collider that you're already used to. But these are not the ECS components. These are basically our traditional components. And down here are the components that were generated based off these three in the transform right here when we created our cube. So, what we are looking up here in our main inspector, these are not the entities that ECS is using, okay? Instead, these ones down here are, okay, this large list here. Now, how can we actually see all of these properties? Well, to do that, we need to change the way we are looking at our inspector. And to do that, we're going to go to the top right where we have this little circle here. We're going to select that, and you can see we can change the type of inspector we have. By default, it is set to authoring, which is basically the traditional way of seeing our components and everything. But we are instead going to switch it over to runtime. And runtime is going to be displaying all of our ECS components that are attached to the entity, okay? And you can see here we have a large list of them. We have local to world, which basically acts as our transform component, chunk world, render bounds, editor render data, all of these right here. Now, initially you may be thinking, okay, these are just like normal components, okay? They're basically just scripts with variables and logic that we attach, but no, it's a bit different than that. The way ECS components work is that a component, unlike a script, does not contain the logic or computational things that a script may normally have. Instead, an ECS component is merely a list of data, okay? It's merely variables, data. So everything you see here, for example, material mesh info, this entire component, all it contains is these two values, material and mesh. It doesn't contain any of the logic that would then process its information. That is done on a more abstract system script that reads this data and then modifies it, okay? So none of these components have any functions or any sort of processing going on. These are all merely components which hold data. Now, why do we do it that way? Well, this is great because unlike a traditional workflow where data is stored wherever there is space, Unity's ECS system stores similar data in chunks, essentially in memory. So for example, if we have local to world right here, this component is going to be stored alongside every other local to world component that is attached or linked to all of our other entities. Now, why is this a good thing? Well, let's just say we have a game where we want to have thousands of enemies running around on screen at once. We might have a component that keeps track, that is like an enemy component. Well, in memory, that enemy component is going to be stored alongside all of the other enemy components in a single chunk or multiple chunks that are all together in memory. So whenever our CPU wants to access those pieces of memory, it doesn't need to be looking around the place for everything else, okay? Because traditionally, when we create components and C# scripts inside of Unity and attach them, that data is stored, wherever there is space in the memory. So traditionally, if we had 1,000 enemies in our game, those enemy components would be, one point in memory, another one over here, another one over there. And when our computer wants to process that information, it would need to search, thousands of different places, jumping all over, and that would then slow down performance. Whereas with ECS, these components are all stored together in chunks right up next to each other. So when our systems want to begin modifying and reading the data, it doesn't need to go far in order to process thousands and tens of thousands of operations in a very short amount of time. And this is where the performance increase with ECS comes into play. Okay, so if we go ahead and play our scene, it's going to look normal because we're essentially just rendering a cube to our screen, but this is done through the entity component system instead of the traditional game object with script components attached, the way we're all used to. So yeah, on the surface it looks basically the same, but later on when we start, really putting it to its test, we'll really see the performance increase that we can get from ECS. So once again, we've created an entity here inside of our subscene, and inside of this entity we have a number of different components, which is basically representing data. Now, each of these components are also going to then have a system which processes that data, okay, the actual logic that is being applied. But that system logic is not stored here in the components or in the entity, okay? The entity is basically, you can think, an empty vessel which contains components, which contains data, okay? All of the logic and processing power is run by these abstract system scripts that are outside of these individual entities, okay? So for example, if we had 1,000 cubes, we are not going to have 1,000 instances of the local to world system running this code. Rather, there will be one local to world system that manages thousands of local to world components, okay? Now, in the next lesson, we are going to be looking at how we can actually begin to create a component and from there create a system that can then modify that component data to change what we see inside of our game. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be going over setting up our components for our entity. Now, the first thing I'm going to do is actually go ahead and delete the cube because instead of a cube, we're going to be using a red sphere, okay? And later on, once we add in thousands of them, it's going to create a nice visual. So I'm going to go ahead and delete the cube here from our entity subscene. I'm then going to create a brand new 3D object of type sphere. This is going to be turned into an entity, of course, as you can see here with the entity baking preview. We can then rename this to be ball. And then let's also apply a nice red material to it. So down inside of the assets window, I'm going to create a brand new material right here. I'm just going to call this one red ball. And we can just attach it as normal, so we can drag it on to the object like so, and then change the color here. Alright, there we go. Now, the next step is going to be creating our component that we can then attach to our entity, because right now, as you can see in the inspector, we have all of these components here, and we want to create basically a ball data component. Now, why do we want this? Well, in the example we're creating here, we are going to have our ball moving around the screen randomly, okay? So we need to create two variables for our ball. We are going to create a speed variable and a direction variable, okay? So a vector for the direction and a float for the speed, okay? How many units per second they are going to be moving. So for this, I'm going to go and create a new script. Now this is going to be called, actually first of all, to create a mono behavior script, and this is going to be called our ball data. Now you can call this script whatever you want. There is no real restrictions over names of scripts. You can generally call them what you wish. So we are then going to open this up inside of Visual Studio. Okay, and here inside of Visual Studio, we can begin. So to start, we are not going to be having this class of type mono behavior, okay? This is not going to be attached as a component, this script. Rather, it is going to be a struct containing data. So I'm going to start by deleting void and updates, start and update, I mean, since we won't be needing those. We then want to go to the top here and add in 2 new libraries. The first one is going to be using Unity.entities, which is going to allow us to access all the classes and libraries related to ECS. And the second one is going to be using Unity.mathematics. Now, when it comes to the maths libraries and vectors, we are using a different library in ECS than we would with traditional Unity. In traditional Unity scripting, we would use vector3 to capture an X, Y, and Z direction or vector, whereas inside of ECS, we use something known as a float3, and we'll get into it in just a second. So first of all, we need to modify our class right here. The first thing being is that this isn't going to be a class. This is going to be a struct. So replace the keyword class with struct. And this is just going to change how this structure here is stored. Okay, a class is going to basically create one instance of that, and then we're going to reference that, whereas a struct, every time we reference a struct, it creates a new set of data. And that's just the workflow that ECS uses. And then instead of mono behavior, we are going to be implementing the iComponent data interface, okay? And this defines this script here as a component, and now we can fill in our variables. So we're going to have 2 variables. We're going to have a speed and a direction. So here I'm going to create a public float called speed, okay, just as you usually would. And then we're going to create a vector for our direction. Now traditionally we would go public vector3 direction, but this is not going to work, okay, because when we are interacting with ECS components, we have to use the new mathematics library. Now you can of course go online and look at the individual aspects of this, as there is quite a lot of stuff. It basically replaces all of Unity's existing mathematics libraries. So we are going to replace vector3 with float3, okay, and this is essentially the exact same thing as a vector3, okay, but each value is being stored as a float. So we have x, y, z, 3 axes, float3. And there we go. That is our ball data script here. Okay, now we need a way of actually attaching this ball data component to our ball, because right now you can see if we click on our ball and if we are in the runtime here in the inspector, you can see that we have all of our components attached to the ball, but we don't have the ball data just yet. So how do we actually attach it? Well, if we go back into our authoring inspector where we have our components, we can't simply just drag and drop this in because it's not of type mono behavior, okay? We can only attach mono behavior scripts as components. So what we need to do is create what is known as an authoring script. And an authoring script is basically a middleman. Its job is to basically attach this component to the entity. So what I'm going to do here is I'm going to create a new script called ball authoring. So we'll create this here, ball authoring. We can then open that up inside of Visual Studio. Alright, so in this script, we are basically going to create a baker, which is going to bake our ball data component to the entity. So to begin, we're going to delete start and update. We are still going to keep this class as a mono behavior because we're going to attach this to the game object. And then at the top, we need to, of course, be implementing the Unity.entities library and Unity.mathematics, since we are going to be using that float3. Now, down here inside the class is where we are going to enter in basically the properties here that we have already created so that we can actually modify them in the inspector. So essentially, we can just copy and paste our variables and put them right there as we've done before. And now to actually bake our component and attach it to the entity itself, we need to create our custom class, which is going to do exactly that. So this class is going to look a bit like this. We're going to go private class And I'm doing this inside of ball authoring because this class is only ever going to be used by this script, so we don't need to actually make it a public one. We're going to call this one Baker, and it is going to extend from a Baker class, and then we can define a type here. Now this has to be of type authoring type, which is going to be our ball authoring script right here. So it'll extend of the ball authoring type there. And then inside of here, we need to define an override function. Now this is going to be a public override void called bake, and it is going to have a ball authoring parameter here. And inside of this function is where we are basically going to get our entity that this script is attached to. We are then going to attach a new component of type ball data. Okay, remember this here is the component we want to attach. And we are basically going to transfer these properties that we have defined here in ball authoring over to our ball data and then attach that as a component to the entity. Now we'll be working on that in the next lesson and seeing if it works. So thanks for watching, and I'll see you all then. Welcome back. Let's continue on with our ball authoring script. Now remember, the ball authoring script is basically acting as a middleman. This is where we can set our properties in the inspector, and then at the start of the game, we are basically running this bake function down here, which is going to first of all get the entity that this script is attached to. So it's going to get our ball entity, and then we are going to attach a brand new ball data component to that entity, okay? Because we can't simply drag and drop ball data onto the ball game object. That's just not how things really work, because we can only attach mono behaviors to game objects. So that is why we are using this mono behavior as, like I said, a middleman to then bake on the actual component itself. So down here inside of the bake function, we want to do two things. First, we want to access the entity that is basically attached to the game object this script is on. So to do that, we can simply create an entity variable here, call it entity, and this is going to be equal to get entity. So it's going to get the entity that the game object is on. Then what we can do is define the transform usage flags. Now this basically determines how the transform components are set up, and there are a number of different options. So basically, if we're setting up a management component that isn't really going to be moving around or visible in game, we might set that to be none. For example, if we're creating a game manager, an audio manager, something like that you want as an entity. But since we are creating an object that is moving around, we want to set this to be dynamic because they are going to be updating and changing their position and scale and rotation over time. So we'll set that to be dynamic. Now the next step is going to be attaching our ball data component to this entity. And we can do that by calling the add component function. We have two parameters. We have the entity and the component. So define the entity right here. And then for the component, we want to create a new instance of the ball data struct. So here I'll go new ball data. Opening and closing squiggly bracket is where we can basically set or establish the variables. So basically what we want to do is we want to set the speed and the direction of our ball data to be the speed and direction of our ball authoring, because remember, the ball authoring script is attached to the game object, so we can modify these values there, and then here is basically where we want to pass them over to the component. So for this, we are simply going to go speed equals authoring.speed. And once again, the authoring we are accessing here is the ball authoring, which is being sent over in the bake function, okay? So it's basically this right here. And then we want to then go direction equals authoring.direction. And there we go. That is everything we need to do for our ball authoring script right here. We have our variables that we are basically having to set up in the inspector and then transfer over to the baked component. And down here in our bake class, and this is where we are actually baking or attaching the ECS component to the entity itself. So we can save that, go back into the editor, and actually look at how we can then set this up. So now that we have a script that is of type mono behavior, this means we can actually attach it to the game object itself. So if I select the ball right here, and if I then drag on ball authoring, like so. You can see it attaches the ball authoring component here. We can then define some parameters, maybe direction, we want to set y to be 1, speed we might set that to be 2, okay, so 2 units per second going up. Now if we switch over to our runtime inspector, you can see here that if we look through, we have a new component called ball data, and you can see the speed is 2 and the direction is 1 on y. So whenever we go ahead and we modify the actual component attached, the ball authoring component, so speed, we might make that 1.5. You can see if we go to runtime, those changes will be applied to the ECS component right here, okay, which is great. So that is how we can attach components to our entities. Now, this entity has the ball data, but it doesn't actually have any of the logic behind it, okay? It knows its speed, it knows its direction, but how do we actually apply that? Now, what we don't do is go into the ball data struct and begin creating functions here, okay? Because remember, when it comes to the system side of things, none of the logic or the processing is done on the component or on the entity, okay? So ball authoring and ball data are pretty much complete. If we want to add more variables, then we simply do that. But if we want to actually start reading and modifying this data, we have to do that in a separate script, which is going to act as the system. And the system is not attached to this ball game object, ball entity, or ball data component. The ball system is going to be its own exclusive script, which is going to basically run or process logic for every single instance of ball data in our game. So in the next lesson, we'll explore how to set that up. Hey everyone, in this lesson, we are going to be looking at the third element of ECS, which is system, okay? And the system is where we actually define the logic for our components on our entities. So we have our entity, which is basically the empty vessel which links to a number of different components, as we can see here in the inspector. And each of these components references a number of different pieces of data or variables, but they don't actually do anything. These components themselves, all they know is that they have this information. They don't know what they want to do with it or what it is for. That is where these systems come into play. And the systems are basically the scripts which look at these components. It can then modify that data and then read it and then do stuff based on whatever we wish, okay? So in our case, we are going to create a ball system which is going to read our ball data, speed and direction, and then modify that with its transform here along that direction at that speed. So to begin, we are going to create a brand new C# script called ball system. Now, when it comes to systems, since these aren't going to be specific to any one game object like traditional components, we aren't going to be attaching this to a game object. In fact, we're going to turn this into a struct, okay? So this script is going to exist in the code base, and at runtime, it is going to identify all of the entities that have a ball data component and then run this code on them, okay? So let's open up ball system right here. And there are a few things we need to do. First of all, we need to add in our libraries. So we are going to be using unity.entities. We are also going to be using unity.mathematics to access, like I said, the float3 vectors. And then we also need to be using unity.transforms. And this is going to allow us to modify transform positions and stuff like that. Now, the next thing we need to do is go down to our class, and we first of all want to change this class into a partial struct, okay, is because we are using what is known as an unmanaged system, okay. Now there are also managed systems, and using one or the other is probably going to be something that you could debate, but generally using the unmanaged system is going to be the best, as this allows us to use the jobs and burst compile systems, allowing for very fast code and very fast games. So instead of mono behavior, we are instead going to implement the iSystem interface, which is going to turn this into an unmanaged system. Now, the main difference is that with a managed system, for example, we would be able to utilize and store and use any sort of data type, whereas with an unmanaged system that we are using, we are limited to the basic stuff like floats, ints, bools, float3s, those sort of things. But for 99% of the stuff you're going to make with ECS, that's going to be fine. And the benefits of having a very fast runtime and compilation and being able to use multi-threading, assigning jobs, is going to outweigh the negatives greatly. Okay, so this is what we're going to stick to in this course. Now, what we need to do is we are first of all going to create a function called OnCreate. So I'm going to create a public void called OnCreate. And in here, we're going to send over a parameter, and this is going to be a reference to the system state variable, which we'll just call state. Now, OnCreate is going to be called at the start of the game when the system is first initialized, okay? And what we are going to do here is basically tell this system to only run if it finds a component of type ball data, because if there are no ball data components inside of our game, well, we don't want to be running the update function. So here we are simply going to go state.require for update ball data, okay? So this is just general practice. We're not really going to run into any errors if we don't have this, but later on when you might have certain components that don't come in until later on in the game, you can run into some errors there. So basically what we are doing is we are saying that the following update function should only run if there are existing ball data components in our scene, okay? Now what we can do is create the meat of the system, which is going to be our onUpdate function. So we're going to create a public void called onUpdate, which is going to have a reference to the system state called state. And in here is where we are basically going to be creating our jobs that we want our balls to do. Now, what is a job? Well, essentially a job is a process that we can then create and then queue to be run on the processor, okay, on the CPU. Now, why would we do this over just running the code when we get to it? Well, because when that happens, we are sort of cramming all of the code into one single thread. So it has to go line by line, operation by operation. And if we have thousands of these operations that we want to run, for example, if we have thousands of balls in our scene, well, that's going to slow us down. So what creating jobs does is this essentially allows us to implement multiple jobs, multiple processes to run at the exact same time using the multiple threads on our CPUs, okay? Because nowadays, most CPUs have, at least 4 cores, okay? At least 4 threads that it can run. So what jobs does is it schedules jobs to be run on different parts of the CPU. So instead of having to go through 1,000, ball update functions every single frame, step by step, instead, we can divide that up into maybe, 10 different chunks that are all running at the same time. So that's the benefit of jobs, and that is essentially what allows us to use multi-threading here inside of Unity to get some insane performance increases. Okay, so how do we actually do this? Well, first of all, we have to define a job. Now, to do that, I'm going to go down here and I am going to create a brand new class. Now this class is going to be inside of our ball system because this is the only place it's ever going to be used. And we're going to create this and it's going to be called a public partial struct called ball job. Okay. And this is going to extend from iJob entity. Now inside this struct, this is basically where we are going to be running the code for the ball. So for this, we're going to create a public void called execute, and this is going to have 2 parameters. We are going to be sending over the ball data, okay? So we'll be sending over the ball data component, and we also want to be sending over our local transform component. So ref local transform, and we'll just call this one our transform. Now, these parameters here are totally custom. We can define whatever parameters we want, and this is essentially the components that we want to read and modify, okay? So, of course, we want to be reading and modifying our ball data because this contains our speed and our direction, and our local transform component, which we saw in that big list of entity components, this is going to contain our position that we are then wanting to update. And then there's going to be a local transform system out there, which is then going to apply that in rendering and so on and so forth. So all we want to do is modify this component here. Now, when we are running this, okay, this is essentially going to be called every single frame, and we are going to be wanting to move our ball. Now, generally in Unity, when you're moving something in the update function, you want to be utilizing the delta time variable. Whereas here, since we aren't really running in the update function and we don't really, it's sort of disconnected, we kind of want to send over some data as well. Now, we can send some data over with our job because the job isn't going to be able to access the delta time from inside here. So we need to sort of cache that beforehand. So up here inside of the struct, I'm just going to define some variables. So we can go public and then float for delta time. And then down here in the execute function, we can then access this delta time. Now, how do we actually go ahead and create a job? How do we establish all of this and let it run? Well, we do that here in the onUpdate function. And in the next lesson, we are going to be implementing that. So thanks for watching, and I'll see you all then. Alright, so welcome back. Now what we're going to do is inside of our onUpdate function, this is essentially where we are going to schedule a new job and then apply that. So here's what we need to do. Inside of onUpdate, we are going to create a ball job. So we'll go ball job, call it job, equals new ball job. And then inside of the squiggly brackets is where we can define our delta time. So for this, what we're going to do is we're just going to go delta time equals. Now, traditionally, we'll just go time.delta time, but that's not going to work for us because inside of ECS, we have to use its mathematics libraries and system libraries. So for us, we're going to go system API.time.delta time, okay? And that is how we can access the delta time. And there we go. Then what we need to do is we need to schedule this job. So we basically need to go, okay, we have this job and we want to run it. And if there is an available thread, it will take it up and it will run the job. So here we can then just go job.schedule parallel, okay? And that is what we need to do for the onUpdate function. Now down here inside of the ball job struct, inside of the execute function, this is where we are going to be running basically the update code, okay? Think of this as our onUpdate function. So what we are going to do here is we are basically going to move our ball based on its direction, okay? So what we're going to do is we're going to create a line like this. We're going to go transform, which is accessing our local transform component, which defines our position, rotation, scale. We are going to equal this to transform.translate. Now transform.translate, this is something we have in Unity already. It basically applies a vector to the position. So in here, all we're going to do is we are going to get our ball direction that we defined in our ball data component. So here we'll go ball.direction and then multiply that by the ball.speed and then multiply that by the delta time, okay? And there we go. So that is how we can modify our speed, because essentially what translate does is typically in Unity this would just be a function, a void function, but here it is a function that returns the local transform component. So we are basically assigning the transform component to be this new modified version with this translation applied. And that is all we need to do. So we can save that. We can then go back inside of the editor. And since the system script, like I mentioned before, is not, based on one specific instance, we don't have to attach this to anything else, okay? This exists in the code base. And all we need to do now is make sure that we have our ball data component attached, make sure all the properties are assigned as we wish, and then we can simply press play. Now, as you can see, the ball is now moving up. And you can see here in our local to world component, or in our local transform component, we can see that the Y position is being modified. So this is essentially the component that we are accessing to translate, and we are reading the data from ball data here. So there we go. Now, we could also go ahead and duplicate our ball multiple times, so we can create multiple different ones here. And you can see that they are all going to do the exact same thing because they are all utilizing the ball system and they are all running the exact same code. Now, with this, we might want to start adding in some variation. And in the next lesson, we are going to be exploring a bit more into the new Unity mathematics library, as well as looking at how we can start applying some randomness to the direction we are moving in. So thanks for watching, and I'll see you all then in the next lesson.